Yes.
Hello, ma'am.
Yeah, yeah.
I can't see anything. Are you sharing screen or
Oh,
is it just me?
okay, yes. Thanks for telling me. Can you see now?
Yes, I can. Thank you.
Okay. So anyone who is not able to do installation, you can do it right now. It doesn't take much time. So first of all, we check our version. I'm sending the commands on chat also. The second thing you have to do, you have to add a repository, R repository. Next thing, we will add the keys. After these two steps, next step is sudo apt get update. So it will update your files. It will take time. It might take 2 to 3 minutes depending how when you have done your last update. If you have recently installed it, it will not take much time. So once you are done with this, the next thing is to install your R. So this will install your R, R interpreter. Once R has been installed, we will install R Studio. Any problems if someone is doing with us? So R Studio, for R Studio, these are the files. So you have to download the file, run it, and then we remove the file. Okay. So that's how your R and R Studio will get installed. In case you are using Trusty, then the first step in which we add repository, the line where we say tab httpc ran rstudio.com then linux ubuntu then yeah, it becomes Trusty. So let me know if somebody is facing any problem. Otherwise, we will move towards vectors. So let's do a quick recap of what we did yesterday. We understood the history of R, how so we Installation guide has not been shared. I thought it was. You all have access to Google Drive, right?
Madam, one quick question: where this installation document placed in the shared drive?
Actually, I sent it to Sri, and he told me that he has uploaded to the drive. Um, so
Even I have verified under R, I don't see any installation
you don't see
document.
any installation document. So let me confirm with the Sri once again where he has uploaded it. Okay, and
Okay.
then we will let you know. In case you are facing any problem when this document get uploaded, just share the screenshot. Maybe we can help you.
I can see the document. I just pinned that path.
Okay, yeah,
They can try.
it's there. Okay.
In the drive, it is there.
Okay, so shall we proceed? So we had a session over introduction of R. We learned how R was developed, what is S, how S and R are related to each other. So S is a statistical programming language developed by John Chambers, Rick. Then we saw the history of R. It was created by two professors of New Zealand, University of Auckland in 1991. Then we saw what are the features of R. R is a R is used for data manipulation, modeling. It has strong visualization power. So R has pretty much all the things which any language has, but it is not a procedural programming language. It's a functional programming language. We focus on what we are trying to do, what function we are trying to write, or what functionality we are trying to achieve. Then we had a comparison of R with other statistical software. So this is a comparative study of R with SAS, SPSS, and Python. So R and Python both are free. SAS and SPSS, they are licensed version, so you need money. Okay, Santosh, I will have a look over it once we are done with the. So yours is use something. Oh, DPKG. Hmm. Fine, Santosh. Once this session will over, I will tell you what needs to be done with this. Don't worry, it's a small problem. Okay. Okay. So we were discussing the comparison of R and Python with the SAS and SPSS. R and Python are free, and all the latest functionalities and algorithms, be it in machine learning or any other domain like physics, astrophysics, or genomics, they are available on R and Python. But SAS and SPSS are a little bit slow because the functionality is developed by a company. They have people and they develop it as and when they feel. But since R is contributed by all the people in the world, and sometimes people take a project, PhD project or thesis that they will write this functionality and contribute to R. So that's why R is so rich in functionality. In documentation, R is extensive. So even CRAN has a pretty much detailed documentation. SAS also has good documentation. Python and SPSS are not so extensive. But since Python is a freeware, so people are contributing to it and it is becoming popular. So gradually The documentation will be there. Visualization. So R is a winner in terms of visualization because there are so many programs, even for a single plot, if you want to plot a map or a simple bar graph or scatter chart. So there are various ways of doing it, and you can control color, size, like, uh, options for having different type of symbols. So that way R is very powerful. SAS is improving because they have to compete with R. SPSS is not so good in terms of visualizations. Python is also good because there are a lot of libraries, a lot of like Plotly. So these all libraries can be included with R as well as Python. So now people are trying to code in such a manner to develop functionality that they can be adapted by both the languages, both the environment.
What is explanatory modeling, madam?
Okay, so explanatory modeling it's basically when you uh, explain the things in terms of graphs, and predictive modeling when you try to predict something in terms of through regression or logistic regression, time series analysis. They are all part of predictive modeling. So likewise, we have explanatory modeling when we explain why this thing has happened. And explanatory modeling consists of your visualizations also. So you explain the effect through graphs. They are by seeing itself you can explain, okay, this has happened because this was a problem. This is known as explanatory model. I could we will see it in detail. Okay. Then we did the R environment setup. So we can install R on Windows, Linux, or Mac. And in Windows, it's pretty much straightforward. For Linux, for Ubuntu, we did it right just few minutes back. And Mac is also simple one. So in Windows and Mac, you have to just download it and run the installation file. In case of Ubuntu, we can do it either software update or through this sudo apt update. So R has two parts. One is R interpreter and R studio. So R interpreter is a place where we actually do all the programming, run all the graph, etc. R studio is a wrapper over R. So it's like as you are trying to write a Java code in a text file or in Eclipse. So in a text file, you have to remember all the syntax. There is no help. But when you write it in the Eclipse, you get some help. Okay, what is the syntax? What is the next value? What will be the column of the files? So RStudio helps in this manner. So it's a little bit easy to work with the RStudio. So it's up to you. You can work on R Shell also or RStudio. But I recommend you to work on RStudio because there you can open. RStudio has 4 sections. I think I explained yesterday also. Let's see if I have my studio. So this is our studio. So left side we have our interpreter. This window is same as our interpreter. At the right side we have 2 sections. The top right is for environment variables. So let's say if I created a variable x, so there will be one entry which I can see in environment variable. The name is x and the value is 2. Let's say I created another variable. So one more entry in environment variables. So here are all the variables which are existing in our environment. Next is the history tab. So history will contain all the commands which I have executed in today's session. So right now I executed 3 commands, so I can see them. You can save history in case you want to save all your work before closing the session. Then we can save this history. It will create a file as .r history file in your working directory, and later on you can retrieve that file. In bottom right we have many tabs. So first one is the files. It will show all the files in my working directory. The next is plots. It will show me a plot if I am executing a plot. Packages. It will give the list of all packages which are installed in R right now. So as and when we keep on installing a package, we can see the name here. Next tab is help. It is for help command. Let's say there is a function sum and I want to see help on it. So that
Can you please repeat what is plots once again?
okay. So plots, whenever we create a visualization or a graph in R, that plot will come in this tab. Let's say I created a pie chart or a bar graph on my R interpreter. So that graph will be displayed in this plot tab. That's the
The
purpose.
output you're saying
Yes,
basically, right?
that's the output. Yes.
Okay.
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 So next was packages. In the packages, we can see the list of all packages which are installed on our R. Fourth is help. So in case I need any help, so that help will be displayed in this tab. So it's like the output only. Okay. So it's me telling me that mean is arithmetic mean, and what are the, it will give me a synopsis of the function, arguments, example. So our help is very good. For each and every function, they have created the structure of that function. They have explained the arguments. Even they give the examples also. So if I scroll down, I can see there are examples, references, value, arguments, and usage. For each and every function, the details are written in this manner only. And next is viewer. So we use actually some plots. Let's say we are creating a map. We are trying to see the crime rate of US or crime rate of India. So we are creating a map, and that map will be, you can see that map in this viewer other than plots. So it's again its output. So this is the structure of RStudio.
Excuse me, Rakhi.
Yes.
Can you again increase the font size a little, if you
Yes.
don't mind?
No, I will increase it. It was just RStudio. So I will start working now.
All
And
right. Okay.
okay.
All right.
So I was just
Yeah,
showing the
this is
whole
clear. Yeah.
structure. Yes, I was just explaining the structure of RStudio. So that's why I kept it small. So this is our R interpreter. And today we will work with the vectors. So I can see still some are not able to install R, right? So I request them, if there's, once this session will get over, we can see their problems. And how many of you are having problem? I can see Santosh is facing problem. Anybody else except Santosh? Santosh, are you installing this R on the Hadoop server where you have Hadoop? Yes, I think so. Because uh, Santosh, you need to send me the previous screenshot also. Okay. So I got one more thing from Prashant. Same problem or it's something else? See, if you're getting DPKG problem, like Santosh is getting, user bin DPKG, it's written like this. User bin KG not found. Written on it. The problem is your APT is locked. It is being used by some other process. That's why it's not letting you install it. But don't worry. We have to just either we will kill this process or we will overwrite it. It will be done. Okay. So in the meantime, we will start with our vector part. So yesterday we discussed about atomic data structures. Yeah. Few things about workspace. So workspace means all the variables. So whenever you are working in R, when you are when you're closing it, it will ask you whether you want to save workspace or not. If you want to save all your variables, all your files which have been uploaded to the R, then we choose option save workspace. So whenever next time I will open my R, all those variables will get loaded. So I don't need to load my files, create the vectors or matrices. So if you need that, then just press yes. It will automatically save the file in your working directory, and next time when you open it, it will load all the variables from your workspace. So you have to just choose the option yes while closing the R. Okay. Now next thing is working directory. I think we discussed this yesterday
So,
also.
so what happens to the values when we store it in a variable? So that will also get loaded next time.
Yeah, that will also get loaded next time. That's the thing which will get loaded next time. If you want to load the instructions also, then you have to load history. So there are two things. One is workspace, one is history. When we say save workspace, it will save all the variables, but commands will not be saved. So whatever, if you have done 10 steps, created a vector, deleted a item, then added something. So all these steps will not save. It will just save the last value of that variable. So let's say you created a variable x. Initially it was 2, then it was a name, then it was some logical value. So the last value, which is the logical value, will get saved. And when you next time open your R, you will find that value, the last one, which you modified in the last. If you choose to save history, the history will have all the instructions written in a history file. You can see the commands. I did this, and you can run the history file again. So it will execute all the commands which you have done day before, which you have done in earlier setup. So that's the difference between workspace and history. Okay. So next is working directory. I told you yesterday also, working directory is a directory on our laptop or computer, which is from where we pick our files or save our data from our. So if I want to take a export of a file, it will be automatically saved to working directory unless until I mention a different path. And if I want to upload a file, I can upload any file from my working directory without mentioning a special path. If it is lying somewhere else, like you have mentioned your working directory at C:/R, or in a Hadoop like home space home/R, so it will directly pick the file from there if it is there. If it is somewhere else, you have to mention the whole path. But we will do it with an example. So next is atomic data type and non-atomic data type. So yesterday actually we were discussing these atomic data types, and I created, so there this way I created it. So we can have a variable as x equal to 2. I can have x equal to data. So now x is a string. I can have x is equal to 4 plus. Now x is a complex. We can have x is equal to true. Now x is a logic. So we can put any value in a variable. And all these are atomic data types which contain only single value. So there are 5 atomic data types. We have character, we have numeric, integer, complex, logical. So majorly we will be working with character, number, logical. Now using these atomic data types, we can create non-atomic data types. The first non-atomic data type which we are going to discuss today is vector. So let's understand what is a vector. Vector is simply a collection of values. Let's say I want to store the number 1, 2, 3, 4, 5. So x is equal to c 1, 2, 3, 4, 5. So x is a vector of numbers. You can, if you know any other programming language like C, Java, they have arrays. So it's like an array, but it is one dimensional. We cannot add any other dimension to this vector. Now I want to create a vector of, we always prefer to use V for a vector. V equal to C
No, roughly what is C stands for? Just like that, right?
C, you can think C stands for collection. So C is a syntax.
Okay, got it. Yeah.
C is a syntax for creating the vector.
Yeah.
Okay. So now
syntax and C stands for collection.
C is a syntax for creating the vector, and C, you can think of it like a collection.
Yeah, got it. Yeah, thank you.
Okay, welcome. So I created a vector of characters. So it has 3 characters. So likewise, I can create a vector of my days, like Sunday, Monday, or we can have a vector of right. So we created so many vectors. We can have a vector of true false, logical vector. So all the atomic data types, they are eligible to make a vector. So we can have a vector of number, a vector of character, vector of logical, vector of complex number. Now what is the purpose of this vector in R? I created a vector of 100 numbers. Okay. Okay, first let me explain all the method of creating a vector. So there are 4 ways. You saw the first method with the help of C. When there are certain random values which we want to collect as a vector, we use function C. So C is a function for creating a vector. Another method of creating a vector is 1:500. It will create a sequential vector. We give the starting value, we give the last value. And it can be given from anywhere. So 10 to 100 or vice versa. Even we can give negative numbers. Okay. So it can take negative, it can take positive number, it can go reverse order, forward order. But the difference will be, it will be sequential only. It's not like that I can give 2, 4, 6, 8, 10. So it needs to be sequential. So column we can use when we want to create a consecutive set of numbers. But what if you want to create a vector with where there is a difference, like each the difference between the two consecutive numbers needs to be of 5 or 3. So for that we have third function called sequence function. So let's see another method of creating vector sequence. It needs 3 input. First will be the starting value, last will be the second will be the last value of the sequence, and then third will be the difference you want to keep in your sequence. Hello. So there was a network disconnectivity. Hello. Sorry, there was a network disconnectivity. Hello. Sorry, network. Sorry, the network was disconnected. So we were understanding the different methods of creating vector. So we did C function to create a vector. Then we did okay. So we learned three methods. The first one was with C function. Next was with colon. That p is equal to 1:10. We can create a vector of 10 numbers. Then third is sequence. So we were discussing this sequence method to create a sequence of numbers. So we use sequence whenever we want to create a vector with a certain amount of gap. Let's say we want to create a vector with all the numbers multiple of 5. So we give the first value 0, then 100, and the difference we want between each number is 5. So this will be the vector which will be created. So if I start this vector with 1, so you will get this number, this sequence. It will start with the starting value 1, keep on adding the difference which is given in by, and it will go till the last value. So it's like a for loop, or you can say precisely while loop. Now there's one more method in this sequence itself. If you don't want to give the last number, let's say I want to create a sequence of 50 numbers which will start from 0 and difference will be 2. So for this we have option. We will start with 0, the by will be equal to 2, and length is 50. It means that we want to create a vector of length 50. It will start from 0, and the difference between two elements will be of 2. If I keep this by as 5, so now this vector will also have 50 elements, but the numbers will change. So basically, sequence help us. So sequence help us in creating a sequence actually with a fixed amount of difference. But this difference will remain same throughout. It's not like that the first 10 elements can have a difference of 5, next 10 elements have a difference of 10. We can achieve that, but then we have to use two sequence functions. So let's do that. Let's use two sequences.
Ma'am, one thing, we created a vector, okay, and we want to make some modifications to that. So we want to introduce one more value. Can we do that?
Yes, you can. Yes.
Existing vector?
Yes, you can do that.
Okay.
Okay.
Thank you.
So to answer this question, let's create a small vector. For this, let's understand how do we access vectors. So vectors are accessed with the square brackets. If I write a square bracket 1, it will give me the first element. Square bracket 5, it will give me the fifth element. Okay. Now if I say physics, right now it doesn't exist. But if I want to put some value in it,
I did not understood the length 50, right? What is that? It is a difference it's making there. Can you just explain once again that one?
Yeah, sure.
0 by 2 and length is 50, and next again 0 by 5 length is 50.
Okay. So SCQ is a function for which helps in creating vector. Right? As we use C function or column, sequence is another function which helps us in creating a vector. It required 3 inputs. So if in the first example, I created a vector with the help of sequence function. So first one is a start value. From where we want to start. Let's say we want to start from 1. The second is end.
Okay.
Let's say we want to end at 20. Okay. Third one is a difference. So we want a difference of 2 between each element. Okay.
So it's basically a increment counter, right?
Yes. So now it has created a vector which started at 1, ended at 19, and the difference between 2 elements is of 2. Simply, it is creating a arithmetic sequence. Right?
Right. So, can someone go on mute? I think.
Yeah, that's right. Let's see if I can mute.
Yeah, now my question is the length actually, which I'm talking about.
Yeah.
Length 50, right?
Yeah.
When you said, yeah, that.
I'm coming to that point now. So this is the one way of creating a arithmetic sequence. And another method, if you want to restrict your sequence by number of elements, you don't want to give the ending value. You want, I need 10 elements of this sequence. So right now there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So next time we will say start at 1. Okay, we are not giving the end. The difference you want is of 2, and you want 20 elements in this sequence. So difference between the two methods, in the first one you gave the last value, and in the second one you are giving the length. How many elements you want in your sequence.
Okay, length is basically it's how many elements I want, and
Yes.
based on that it will
Yes.
give me the number. Okay,
Yes.
thank you.
Okay, so they are the two ways. R need either one of them. It has to do the calculation actually. If it is no start value, end value, and by, it will calculate how many elements it needs to generate. And if you provide the element, it doesn't need the last value then. So it will keep on incrementing till the time number of elements it has generated is 20. So
Okay. Rakhi, I have a question here.
yeah.
Like we have specified the starting value and the end value. Okay. So can we have some functions here, like a function for starting value and some other function for
Yes.
by value?
Yes, you can.
And length, then in that case I guess length comes into picture.
No,
That
no,
we
no,
are
no,
not
no.
sure what would be the final value, right?
No. If you are giving end value, then length should not be there. R will become
Yes, but
R will
yes,
become
but
continuous.
what I'm saying is that there is a function, some calculation involved in the
Yeah.
starting value and by
Yes.
value, suppose. Okay.
By value.
Then we are not Yes,
Okay.
yes.
Okay.
Suppose there are some calculations involved here, some functions here. Then we are not sure what would be the end value, right? So we can specify the length that we use this function and calculate, give me 50.
Yeah.
Right? Okay.
Correct. You can do that.
Yeah. Okay.
Very right.
Yeah. Okay. Fine. Okay. Thank you.
So there are the two options which you can choose, but don't put all of them. That start and by length all are there. Then R will not be able to understand what you are trying to do. Okay. So this was the third method. Next is repeat function, REP. So REP is pretty much straightforward. If you want to repeat a value a number of times, so that's what repeat function does. So let's say you want to repeat 2 10 times, it will give you a vector with 2. Or if you want to do a single vector with value 1, so that's the function of repeat. Right? So are we clear with these four functions? The first is the C function, second is colon, third is sequence, fourth is repeat. And I have a script which you can which I will upload, and you have to practice it. Okay. So here I have mentioned method 1. A vector can be created by command vector C. Okay, this is one more thing. You can create a vector by vector also. So let's say I want to create a vector of length 5. Right now this vector, there are no values in this vector. So that's why it's showing false, 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 false. Now I can allocate my values. Let's say v1 is equal to 5, v4 is equal to 7. Now if I again print this vector, I get two values, 5 and 7, and rest are still 0. So that is fifth method of creating a vector. When you want to create an empty vector, and so you it will be needed when you don't know what values you are going to allocate in the vector. So you just create an empty vector and leave it, and whenever you want to allocate the values, you can put them as the requirement of your function or a program. Okay. So now we have 5 methods. So let's see the script ones. The first is the vector method of creating a
Ma'am,
vector.
can you explain me the display process also? I see, I mean, each time the display, beginning of the text, there is a number. I'm just trying to understand what exactly that means. If you go back to the previous commands display, so it's basically starts with 1, and for display it starts with 149.97. What does it mean?
You are talking about.
So the result display. The first part, yeah, first letter of each line.
Oh, this one, 133, 65, 97. This one.
Yeah, it keeps varying for result. I know, I mean, it's displaying the number, but
Yeah, that's
I mean,
right.
how does?
It's the number of the element. So if say, let's say we have 20 elements in our vector. It will keep on changing, you are right. So all 20 came into one line. So we have only one in the beginning. So next time I am displaying 40 numbers. So now they are displayed in 2 lines, and the first element of second row is the 33rd element. So that's what the number it is showing, that this is the 33rd element of this vector, 33. Had it been opposite, let's say 40 to 1, so still you have 33 here. So right now this time 8 is the 33rd element of this vector. So it's the location of this element, but only the first element. The reason of this display is because vector is a one-dimensional data. As we move into the R, we will find two-dimensional structure, three-dimensional structure. So these row and columns are meant to be used as number of row and number of columns. Since vector has only one dimension, it's the length. So it is telling me the length of this element, that it is at 33rd location, or the length of the vector till this position is 33. That's all.
So is it going to vary if we change the configuration?
Sorry, voice is not.
Is it going to vary the numbers if we change the display configuration, output configuration?
Yes. So when I will create a small matrix here. So when it will be the matrix, that is a two-dimensional structure. So this will be like this. So first row, second row. Then on top, first column, second column. So it helps us in understanding the data structure also and its location.
Oh, I got it now. Thank you.
Yeah. Okay. So, okay, don't confuse with matrix right now. We are still not done with the vector. So we understood the method, 5 methods of creating a vector. Now next is, so this script will be loaded on your shared drive and you can practice it anytime. Now let's come to the name part. So let's say I have created a vector of 7 elements, or we have a vector which has the sales figure of our 7 days. 1, 2, 3, 4, 5, 6, 7. Okay, now we want to name them. That what is the first day, what is the second day, what is the third day. So there is a function name v. So 1, 2, 3, 4, 5, 6, 7. So this is the vector with the names. So we have given a name to each element. At first value is of Sunday, second value is of Monday, third is of Tuesday. Now if I want to see the third element of this vector, I will get name as well as the value. So it is Tuesday, 67. Fourth element of a vector will give me a name.
What happens if we don't match or map the elements
With the name.
the values is equal to names? Yeah.
Yeah, it's okay, no problem. You can still work or do all the work.
I mean, if we delete the Saturday, then what happens?
If I delete the started day, that means I do this. It will become like this. You can modify them. Or I can do this. Okay. Name will be there, value will be gone.
Oh, okay.
Or I can add a value. So let's say V8 equal to, now I have another value in this vector, but it doesn't have a name. So name are not mandatory. They are for just for the convenience and to make an understanding of the data. That's all the purpose is. They won't stop you in
So,
any.
Raki, sorry. So, Raki, names are not values to the vector. You're not increasing the length of the vector, are you?
Yes, I increased the length of the vector. I added one more element, 8, in the vector. But I didn't added the name.
No, what I meant was in the previous example when you added the names Monday to Saturday, are those also values stored as values and increasing the length of the vector, or
No,
are
no,
they
no.
just kind of placeholders?
They are just the placeholders. They will not increase the value of the vector. They are just the names for each element of a vector. And it is
basically
not
assigning the name to the element, right?
yes,
For each element.
yes. And it is not mandatory to allocate a name to each element. I can just allocate name to 2 or 3 or 4 of them, like this. Okay. So still vector is there. It will work perfectly fine. Only the names are not there. So they are just the placeholders for the values.
Can we access the elements with the name?
Can we access the element with the name? Yes. When you will access any element, it will give you a name and it will give you the value. If it is not there, it will
I
give
mean to say, no. V of Sunday, V of SUN like this.
V of Sunday, like this.
Yeah.
No, that is not applicable with the vectors. But in later data structures, we will be able to do it.
So, Raki, can you give an example of where these names are used in the real time? Why do we need names for these values?
Okay, it will be too early to give that example, but I will explain you theoretically. Let's say you are summarizing some data, okay, and you want when you want to display your vector in a graph, you want these names to be displayed. So your graph will have the value of Sunday, value of Monday. So you will easily understand, okay, these are the details of your day or of a month. So these are for understanding purpose only. They don't have any role in the processing or programming. So important. See, if we cannot understand what we are talking about, or we cannot explain other, then it will be a little bit difficult to do data analytics. So in every data structure of R, we have a provision of writing names. This is not only with vector. When I will move into 2-dimensional, 3-dimensional, even we can have 4-dimensional also. You can allocate name to each and every element in R. And the reason behind it, when you plot graph over it, these names become helpful to display your graphs, plots, etc. Am I making sense?
Yes, it's clear. Thank you.
Okay, so we understood type of how can we create a vector. We allocated name to the vector. Let's do quickly a mathematical operation on vector, which is the main purpose of creating it. So I created a vector of 10 elements, 1 to 10. I created another vector. Let's take it V1, V2. I always prefer to create a vector with V, matrix with M, and array with A. So that's a naming convention we follow. So that by looking at the name itself, we can understand that whether it is a vector or a matrix. So I created one vector 1 to 10, another vector 11 to 20. So V1 looks like this, V2 looks like this. And I simply want to add these two vectors. Like we do in Excel, we want to add two set of numbers, we put them in column 1, column 2, and put a addition in the third column. So now I will do V1 plus V2. So I got a addition element by element. So first element of first vector is added to the first element of second vector. Second element of first vector is added to the second element of second vector. So element by element addition. Okay.
So can we add even the sizes of those two vectors are not equal?
I was coming to that. Yes, we can do that. So let's say we have a vector with 1 to 5. Okay, sorry. It's better to use 11 to 20. Okay. So V1 is this and V2 is this. Now we want to do the addition. V1 plus V2. So let's see what has happened. 11 was added to 1, we got 12. 12 was added to 2, we got 14. 3 was added to 3, we got 16. 14 was added to 4, we got 18. 15 to 5, we got 20. So till 5, so 12, 14, 16, 18, 20. It's a straightforward addition, element by element. 15 with 5, 14 with 4, 13 with 3. After that, 16, 17, 18, 19, 20 didn't have any pair here. So what it did, it started reusing the vector. So 16 was again added to 1, we got 17. 17 was added to 2, we got 19. 18 was added to 3, we got 21. 19 was added to 4, we got 23. And 20 was added to 5, we got 25. And this is known as recycling of vectors. You might face a question somewhere, or this is a very important concept of R, that R recycles its vectors. If it is running short of a vector in making pair, it will start reusing the value from the beginning.
Can you give me one scenario, like in business function, where do we use this recycle vectors?
Let's say you have certain rates or certain elements which will be repeated after some time. Monday to Friday, 5 days, the discount will be this much. Saturday, Sunday will be this much, and you want it to be repeated again and again. So in that calculation, it will help us. Okay. So yeah, we have to be careful with that. Yeah, it should not happen when we don't need it. It should happen only when we need it. Because if R is running short of a vector, it will start reusing it. So we have to be careful with that. Sometimes it is advantage and sometimes it is disadvantage also. Okay.
Maybe when we want to constant values to the path to the vectors, maybe that time.
Yes, yeah, by mistake you have one element less in a vector, and and you want to apply some different rate or Saturday, Sunday, and otherwise it will pick the rate which is for Monday, Tuesday. So there will be problem. Okay.
Right. Okay.
Raki, I have a quick question.
Yes.
It seems to be kind of V1 you mentioned that 1, 2, 3, 4, 5. V2 you mentioned that's 11 to 20. While adding this data, the first thing should be numbers are, V1 occurrences, vector size should be same. Otherwise, I need to explicitly mention zeros because whatever expected result is not coming. Because see, 11 plus 1, 12 plus 2. After that, again, it's repeating. But in the sense, it's not supposed to take, it's supposed to take the zeros and produce the result, correct? As in other programming language and all, correct?
Yeah, that's why I said R is very different from other programming language. Had it been C, it would have given an error.
So while doing calculations, I need to be careful and whether vector should be same size or I need to explicitly mention it as 0. Otherwise, it will be the wrong results, correct?
Sir, this might be an interpretation that it is giving a wrong result, but that's our behavior. Anyway, it's applicable for all the data structures. Anywhere it is running short of a vector, it will start reusing again. So okay, I understand your point.
But in this case, Raki, I'm talking about in this case, example V1 you mentioned 1, 2, 3, 4, 5, and the default operator is supposed to be the zeros. And V2 you mentioned 11 to 20, and because this is a different size, this is a different size, I'm expecting 11 plus 1, 12 plus 2, 13 plus 3, 14 plus 4, 15 plus 5, 16 plus 0 I'm expecting, because this is a regular programming.
If, if you are expecting this, then you have to create a vector with the 0 values. You are expecting that?
So I hope you understand my question.
Yeah, I understood your question. You want it to be like a normal programming language where we take 0 if it is not there.
Because you are telling that if I won't mention, I need to explicitly careful about putting the zeros, right? I need to put the zeros if I am expecting the same kind of result, correct?
Yes, yes. You have to put 0.
But I think you took a right example, right? I don't know, maybe that is applicable. You said, right, I mean, for example, if, I don't know, I'm getting an echo.
Yeah, so close that.
Yeah. See, for example, right, if I'm setting up in a 30 days and I'm setting a target, and the Monday will be my target, will be say 30, or Tuesday will be 40, and Wednesday will be again. So every Monday, 30 days. So for example, if you start on Monday, so next again Monday it will set automatically that target, right? So that may be one of the examples.
Yeah, actually it depends. I know it's a little bit difficult to come from. Why I'm getting so much echo? Will you please? Okay, thank you very much. So you are right. Actually, this is meant to be done with the data analytics when you want to repeat your values. So let's say vector is working with the array, vector is used with the matrix. Here you want to apply again and again the same value. So your example was right. So we want to repeat the week, or again we want to repeat the same values. So in statistics, it happens a lot of time that we are applying the rates or discounts or values. So it is very different from procedural programming. Yes, in beginning it might sound you a little bit weird that why I'm not getting zeros, but later on as you will move into the R, this is the R way of doing things. So I always say that it's better you don't compare it with the other programming language, especially with C and Java. It's way different from them, and it's easier. There are less rules, less restrictions. R try to take care of a lot of things. So sometimes it is advantageous, sometimes you have to be careful with the way it works. So yes, it will repeat the values, it will not consider them 0, it will expect that yes, you want to repeat this vector again and again for rest of the values. Okay.
Ma'am, are we winding up for today? I got to leave actually.
Yes. Even at 8:45 I have to go. So
Can you do one more thing, right? When you close this,
ma'am, Roja here, ma'am.
Can you save it as a workspace as in a one file and the history as in a one file so we can see it tomorrow?
Sure, I will do that. Yes.
Thank you.
Okay.
Raki, can you share recording? I could not make it yesterday.
Yesterday recording, right? Okay. Okay, I will upload it on shared drive.
Ma'am, Roja here, ma'am. I have a doubt.
Yes, Roja.
Ma'am, what is the command for concatenating two vectors?
I was going to cover it tomorrow. You want it today only?
Okay, ma'am.
Okay. Okay, thank you. Any other question?
I have a question. So, can we take a first vector for V1, 1 to 3, and the second vector V2 is 11 to 20, and still can we add both of them together?
I got your point. So let's do it. 1 is to 3, 3 to 1 is to how much you said? 11, same 11 to 20?
11 to 20. Yeah.
I understood what you are trying to. So it will do it, but with a warning. But it will do it.
Oh, okay.
Okay.
Because they are not, multiple slides. That is it.
Yes.
I got it.
Yes, but it will do it.
Okay.
It will not stop your
Okay.
process. Okay.
Yeah. Thank you.
Okay. I think let's close for today, and we will see you tomorrow 7:30. And for those who are not able to do the installation, I will send you.
Hello, actually, this is Santosh here.
Yeah, Santosh.
I have done it.
Okay, congratulations.
Installation has been completed. Yes, yes. I have executed whatever you said on the class.
Okay.
Successfully run.
Okay, congratulations. So anybody who's left with the installation?
And the class, 8:45 a.m. class started?
Yes.
Yeah, but I'm not seeing anything on the screen.
Yeah, we are starting now.
Okay, thank you.
So yesterday we discussed, we were discussing statistics and we did mean, median, mode. Then we did quartile, decile, percentile. And after that we were discussing the dispersion. In dispersion we discussed mean deviation, standard deviation, the relationship between mean deviation.
Your screen is not visible, madam.
I haven't made it visible. I will make it visible now.
It's blank only.
today the session got delayed by 10-15 minutes.
Can you please share this PPT?
Yes, this will be there for you. So yeah, I was doing a little bit modification in this presentation. That's why I didn't upload yesterday.
Okay, sure.
So we all are okay till measures of central tendency: mean, median, mode, quartile, percentile, and decile. Okay. So we were discussing standard deviation and mean deviation, and I explained the difference between mean deviation and standard deviation. Hello. So I explained the difference between mean deviation and standard deviation. Okay. So any doubt with the mean deviation, standard deviation? Okay, fine. I will explain once again. So this is this. I hope you can see my screen. I took a simple example to explain the difference. Right? These are 4 numbers. So all these this 2 set of numbers, they have same mean deviation 4. And I have done the calculation also. 7 plus 1 plus minus 6 plus minus 2 divided by 4. And the second set of numbers. So both the set of numbers, they have same mean deviation. But the standard deviation is different. For first set of numbers, the standard deviation is 4.74 and second set of number is 4.0. So actually, sometimes the mean deviation is quite confusing. Two set of numbers who have different span, they should have a different deviation. But mean deviation was giving us same figure, 4, which is a little bit confusing. So standard deviation is a more correct method, or mathematically more accurate. And so the first set of number we have 4.74, the second set we have 4. So that's his standard deviation is more accurate mathematically. So people, academicians or mathematicians, they try to prefer use standard deviation rather than mean deviation.
In the standard deviation, there is no absolute values because of squares. So we can get the accurate result, right?
Yes. We take the square, we sum them, and we can take the under root. In case of mean deviation, we take the absolute value, we add them, and divide it by number of values. Okay.
Okay. But in models, we can prefer the standard deviation only, right? Instead of mean deviation?
Yes, we should prefer standard deviation.
Okay.
Okay. So yeah, that was the step where we were yesterday. The relationship between standard deviation and mean. Okay, so before explaining this relationship, I have to explain the distributions. So first I will explain what is a normal distribution. See if I can use a paper. So you all might have seen this bell-shaped curve, right? So let's keep it a little bit interactive, because these concepts otherwise become little bit boring. So you all have seen this bell-shaped curve, right? So the bell-shaped curve stands for normal distribution, where the mean has the highest frequency, the central value is the most occurring value, and as we move towards tail, the frequency decreases. It's applicable for all population data. If we take a population data for any variable, it should follow bell-shaped curve. That is, it should follow normal distribution. If it is not, then it might be skewed. That is, this peak might be shifted to left or right. So we call it as skewed distribution. Like I will give you an example. In this scenario, so the peak has been shifted. In this scenario, the peak has been shifted to right side. In second one, peak has shifted to left side. So this is right skewed and this is left skewed. Okay, and this is the longer tail. And when data is symmetrical, that is normal distributed, then your mean, median, mode all are exactly at the center. So 50% data will be in left side of the mean and 50% data will be on right side of the mean. And when there is a skewness in the data, your mean, median, mode, they are not equal. So in this scenario, mean will be here, median will be somewhere there, and mode will be the most occurring value. So all three are different. We can check this on our R also. So let's create a vector b is equal to 1:100. Okay. Now let's find the mean. So mean is 50.5. Median is 50.5. Same. But if we shift this data a little bit, let's say we create a data 1:10, then let's repeat function, repeat 1:10, repeat 2:10, so let's see the mean of this data. Is it going to median? This one is also normal distributed. Let's change little bit. Okay. So if the data is not normally distributed, the mean and median will be different. And if it is normally distributed, the mean and median will be same. So what has to do now? So if it is normally distributed, so there is a standard relationship between standard deviation and mean. And this is what we have in a relationship. So all the values, 68% of the values will be within one standard deviation of the mean. So do you understand what is one standard deviation of the mean? If the mean is 30 and the standard deviation is 10, what will the value of mean plus a standard deviation? It will be 40. So what I am saying, this is 30 and the standard deviation is 10. So this range will be 20 to 40. So 60% of the data set will be between 20 and 40. And I have an example for that. So this is the example. Let's say n is equal to 200. There are 200 numbers in a data set. The mean is 80 and standard deviation is 10. So mean plus standard deviation will be 90. Mean minus standard deviation will be 70. Mean plus 2 standard deviation will be 100 and mean minus 2 standard deviation will be 60. So 75% of 200 is 150 observations. They will lie between 60 and 100. So for normal distribution, this percentage is 68% and 95%. And for any other distribution, this percentage is 75% and 89%. Actually, the reason of explaining this is this is central limit theorem, and it is very widely used in hypothesis testing. So when we understand this correctly, then only we will be able to do hypothesis testing. Okay. So shall we proceed? There are simple rules that 75% of your data will be lie between plus minus 2 standard deviation of mean.
Ma'am,
Yes.
can you please explain an example for this?
Okay.
See, I understood up to n is equal to 100 and mean and SD, and mean plus SD and mean minus D. And what is this 75% of 200? And I didn't get that line.
Okay. Okay. So 75% of 200 means you have, how many numbers we have? 200 numbers, correct?
200.
So out of this 200 numbers, 75% of 200 is 150 mathematically, right?
Okay, yeah.
So 150 observations, yani 150 values of this data set will be between 60 and 100. So if you are having a class of 100 students, okay, let's take an example. Okay, you are a class of 100 students who appeared in an exam. Okay, and each student got marks like 1, 2, 3, 4, 5, 6. Okay, 1 to 100. Now, I am asking how many students are between 60 to between 50 to 6 between 50 to 70. Okay, I just ask a normal question. How many students have scored between 50 and 70? So your answer will be, since the mean of this data is 50. Okay, since the mean of this data is 50, and the standard deviation is let's say, what is the standard deviation? Let's calculate it here. So we said we have a class of a student who scored 1 to 100 marks. Okay, this is the vector.
Yes.
I calculated the mean. Mean is 50.5. Okay.
Yes.
Standard deviation is 29. Okay.
Okay.
So 50 plus 29 will be
79.
50 plus 29 will be 79, and 50 minus 29 will be 21. Okay. So what you can tell me that we know that 68% student of this class, 68% of this class have scored between 21 and 79.
Okay.
Okay. This is what central.
Yeah, 21 to 79.
Yes, that's what the central limit theorem tells us. That this class.
It means Q1, Q2, Q3, right? We found here. Like Q1 is 21 and Q2 is 50, Q3 is 79, like that?
No. Q1s are, those quartiles are different. If I calculate the quartile of this.
Okay.
Sorry, spelling. So these are the quartiles. They write the function as quantile.
Okay.
So quantile,
Okay.
they divide the data into 4 parts. Okay.
Yes.
It has nothing to do with the number of students lying. So what can I say, that 25% of my students will be ranging between 1 to 25.
Yes.
Okay. Now.
Yes.
That's what quantile tells.
Okay.
But when
that understood, member.
Okay.
Understood. So between 21 to 79, total 68% you are saying, right?
Yeah, 60% of this class is lying between 21 and 79.
Okay, ma'am.
Okay, that's what
Thank you.
central limit theorem says. Okay.
Okay.
So let's move to the next topic. So we understood the relation between mean and standard deviation. We understood why do we need standard deviation. Let's understand what is standard error of mean. You will find it in a lot of places. Okay. So let's first see, in the statistics we work on samples, right? And we want to know how far is sample mean from other sample mean. What do I mean by sample and what is population? So sample, let's say I am trying to check whether who will be the winner in next election. So how many people can I talk? I may talk to 50 people, 100 people, 200. So they are the sample. And by the sample, we are trying to predict the population. So by talking to those 50 people, I am trying to assume what will be the outcome of Delhi elections. So those 50 or 100 people are representing the entire population of Delhi. So because we cannot talk to each and every person, so we have the statistics is basically dependent on sample size. And one thing is also sure that sample size will, if you take a big sample like 1000 people, so it will be better than a sample of 50. So this standard error of mean, this gives an idea what is the possibility of an error with the sample. So the formula of calculating standard error of mean is standard deviation divided by sample size. So I will take an example now. Let's say the standard deviation is, yes, sample will be selected randomly. That you decide before your experiment that we are going to take a sample of 100 or 200. Although there is a science behind that also, that how do you decide sample size. But let's not go into that detail. Assume that we have taken a sample size randomly. So if the sample size is 1 lakh, suppose, and there is another sample with the sample size 100, and standard deviation is fixed. Standard deviation is 10. So 10 divided by under root 100 and 10 divided by under root of 100, 1 million or 1 billion. So which will have a bigger error? So of course, if the sample size is small, your standard error of mean will be large. And if sample size is very, very, very large, this standard error of mean will keep on reducing. So this actually, it's a measurement with the how much mistake we can do with this sample. So standard error of mean will, as the sample size increases, standard error decreases, and sample size decreases, it increases. So it's inversely proportional to sample size. It is a standard deviation of sample mean with respect to true mean. We use it in hypothesis testing of mean. And the probability distribution of sample mean follows normal distribution. Sorry, sample spelling is wrong. So I will explain the last line, that probability distribution of sample mean follow.
Ma'am,
Yes.
ma'am, what is the hypothesis testing, ma'am?
Don't worry, we will cover it. It's an
Okay.
entire lecture over it. Hypothesis testing.
Okay, okay.
Okay.
I'm just listening that word. I'm a bit confused.
Okay. We'll cover it. So yes, now we have to understand what is the probability distribution of sample mean. So we took an example that we took a sample of 50 people, right? So now if I say how many sample can I take of this 50? Different sample. 50 people from one part of Delhi, 50 from another part of Delhi. So any idea how many sample can I take? I can take 1,000, million or billions. So actually it will go into billions. Now I calculate the mean of each sample. Now those, let's take a number that we calculated that there is a possibility of 100,000 samples of 50 size each. And we calculated the mean of these 100,000 samples. So I will get different value of mean. Someone will give me 10, some 11, 12, 13, 14, like that. Now if we plot a graph of this sample mean, this graph will follow normal distribution. So this is what I mean to say, the probability distribution of sample mean follows normal distribution. And its significance, why it's necessary to understand it, we will understand in hypothesis testing of mean. Because when we do the hypothesis testing of mean, we use this assumption that they will be following a normal distribution. So right now we have to understand what is the standard error of mean. It's the ratio of standard deviation divided by sample size. And as the sample size increases, our standard error of mean decreases. If sample size is small, then there is more chances of error in our mean calculation. Okay, pretty straightforward. So let's move to next concept. Variance. So let's take the variance of this one. So this is our V. Standard deviation of is 29 and variance 841. So what is variance? If I multiply this value, let's say I save it in somewhere, is equal to standard deviation of V. And x into x is 841.667. So actually variance is a square of standard deviation. So you will see it in lot of research papers or even hypothesis testing, or in many theses, you will find variance in place of standard deviation. A lot of people prefer to use variance. So actually variance is the square of standard deviation. So let's go back. What does standard deviation signify? It is basically the dispersion. It is the span. And variance is just the square. So why do we need variance when we are taking the same value and just taking a square? Sometimes if we talk about stock market or where rates are applicable, even a minute difference is a big difference. So let's say you are comparing two stocks and they are differing by only maybe few cents or just the difference is in decimal. But even this difference is a big difference. So in such scenario, we prefer to use variance because that value, that difference will be depicted in a clear manner. with the square rather than with the standard deviation. Might be the standard deviation is 29.01 and 29.5. It's not much different. But with the variance, we will see the difference clearly. So we try to use variance in such cases. Even 70 to 80% people are using variance in place of standard deviation. Okay, and the formula of variance is this: sigma square is equal to summation of x minus x bar the whole square divided by n. We don't take under root. So variance has a lot of applications, like risk associated with the stock market is measured in terms of variance. Yeah, there's one thing. When we calculate a variance of population, we use, okay, this is correct. For population, we use n, and for sample, we use n minus 1. Okay. So, any problem with the variance? Shall we move to covariance? I will. So variance is B. B is equal to 1 is to 100. Standard deviation of B1, standard deviation of B2, same thing. Variance will be same. Okay. So let's talk about covariance. So as the variance is a relationship of data with itself, for covariance we need two data set. So let's say we have these two numbers B1 and B2. Now we want to see the relationship between these two set of numbers. So for that we will use covariance B1, B2. So this is 841. Let's take another set of number. V3 is equal to 100 is to 1. So V3 is just the opposite of V1. Now I will calculate the covariance between V1, V3. So what did I get? Exactly same number but with negative sign. So when I need a covariance between two set of positive numbers which were almost same, even I can calculate a covariance with itself also, even with V1. So it's same, right? So first of all, covariance require two set of numbers because we are trying to see the relationship between the two set. So if both the set of numbers are increasing order, that they are moving in the same direction, your covariance will be a positive value. If one set is increasing and another set is decreasing, then your covariance will be a negative number, as I showed you right now. So what does this negative and positive mean? It means that in the first scenario, these two numbers are positively related to each other. One is increasing and another is also increasing. Negative means these two numbers are negatively related to each other. If one is increasing, other is decreasing. Now let's take two set of numbers who are distributed haphazardly. Okay, so let's take one vector V. This one is 5, 89, 23, 78, 34, 90, 12, 67, 10, 34, 98. Okay, let's create another vector. Same vector. Let's make V2 and let's make it V1. Okay, now calculate the covariance between V1, V2. What did we get? Negative correlation. Now V2, V1. Same one. Okay. Now let's take another vector V3.
How is covariance calculated?
Pardon?
How is covariance calculated?
Okay, you are talking about formula?
Yeah, what's the formula?
Yes. Okay. This is the formula. Covariance is a measure of how much two random variables vary together. It's similar to variance, but where variance tells you how a single variable varies, covariance tells you how the two variable varies. So it is equal to sigma, summation sigma x minus x bar multiplied by y minus y bar, where x bar and y bar are the mean, and they will be divided by n. Okay. So a positive covariance means variables are positively related. They move together in same direction. While a negative covariance means variables are inversely related. That is, they move in opposite direction. So covariance has a wide range. It can go up to infinity, negative to positive. So let's see when we have a covariance of 0. So let me make another number. V3. Now let's calculate the covariance between V, V3. So it's negative, but still we have 243, a very high. It's a good number. So more random are variable. Let's take simple numbers. 9, 4, 1, 7, 3. And then let's take V2. 5, minus 9. Let's see what covariance they have. Okay, sorry. One value was short. Okay. See, the number is decreasing. Now we have reached 157. So if there is less relationship between the numbers, this number will get reduced to 0. So 157, still they have some correlation. So that's how the covariance varies. Okay. So any doubt with covariance? Why can't 1 to 100? I don't get your question, Ram Babu. Can you explain it? You want me to take a number from 1 to 100? Oh, V2 2 to 100. I was just showing a relationship. See the two set of numbers 1 to 100 and 2 to 100. They are showing exactly same relationship. They are increasing in the same manner. That's why I took this set of numbers. The two different set of numbers, if they are showing same pattern, Yes, we can take 1 to 0 0 or 1 to 100.
Ma'am, where do we use this covariance?
Where do we use this covariance?
Means why we use?
Why we use? Yes, good
Yeah,
question.
same question.
Yes, good question. I was coming to that. So, one thing is clear right now. Covariance is telling us the relationship between two set of numbers, right? So, as we will move into predictive modeling, regression, you will see all these things are dependent on the relationship between numbers. So, have some patience and we will come to that point. Okay. So, next thing we are going to discuss is correlation. So once you will understand what is correlation, this covariance you will understand the application of covariance. Okay. So now there is a problem with the covariance. The covariance, the range of the value of the covariance is very wide. It can go negative, minus infinity to plus infinity, any number. So with such a wide range, it is very difficult to compare two relationships. For one, I will get 1000 or 100,000. For another set of number, I am getting a value 10, 20. So they are not standard. So we have another concept, which is correlation. So correlation is we move one step ahead from covariance. Coefficient of correlation. Okay. So the formula of correlation coefficient or coefficient of correlation is covariance of two numbers x comma y is divided by standard deviation of x and standard deviation of y, sigma x, sigma y. So when we divide covariance with the standard deviation, we get an output which is between -1 and +1. So let's again check those covariance which we did in R. Okay. So for correlation, formula is COR. So we had one vector 1 is to 100, another vector V2 1 is to 100, third vector 100 is to 1. Okay. Let's check the covariance between these two and then we will check the correlation. So between V1 and V2, covariance is positive, and between V1, comma V3, covariance is negative. Now change these values. We will change this formula to correlation, comma V2. We got a value 1. And for V1, comma V3, we got a negative 1. So what does correlation do? It brings the scale of covariance between 1 and -1. So it's very easy to compare two relationships, to compare the relationship between two variables. So let's see the correlation graph. So if we are getting a value 1, perfect positive correlation, means the two numbers are highly correlated. If one is increasing, then other is also increasing. If the correlation coefficient is negative, that means we have a perfect negative correlation. So one is increasing, another is decreasing. And if the value correlation is 0, then there is no correlation. So all the values are haphazard. So these are the scatter plots which we will find with our correlation coefficient, with respect to correlation coefficient. So as the correlation coefficient decreases, you can see the randomness in the chart decreases. So 1 and -1 are the perfect straight line. With 0.9, 0.5, the graph became more scattered, and with 0 it's no correlation and it's totally random graph. So covariance is basically used to calculate the correlation, and correlation scale lies between 1 and -1. Okay. Now you can ask another.
One question.
Yes, tell me.
Yeah, sorry. Actually, till now, whatever you're saying, it's between the two data sets. We are taking the two data sets and we are finding all this relationship between them. Correct.
Yes.
So, in real, suppose I wanted to just do the one data set and find out all these things. Is it possible with that?
Yes, you can.
So, the skewness, whatever the correlation, whatever you told till now, it will be in the same format, or it will be in, and again, we need to change anything else there?
So you're saying that you have only one data set, right?
Yes, yes. As a testing purpose, I have to use only one data set. It's not. I'm not talking about the real time now. I'm just testing purpose. So for testing purpose, I have to take only one data sets, that which consisting of negative and as well as positive values. Right. Suppose, for example, it in one data set it contains negative and positive. Is it possible to find out?
Okay. Now my question: you have one data set, whatever values are there.
Yeah.
And
yeah.
You
Consider. Yeah. Okay.
With whom you are trying to relate it?
Yeah. Consider that the value in one data set is -1 to 100. It comes from -100 to 100. This is when data set is -100 to 100. That means, yeah.
Okay.
My data set consisting of -100 to 100.
That's okay.
So it consisting of negative and positive values.
That's okay. That's okay. You have all the values. But my question is,
okay,
with whom you are trying to relate it? Is there any other value with which you find the relationship? See, you can have relationship between two variables, right? One variable doesn't have any relationship with itself. Then
correct, exactly. Yeah.
So that's why for correlation and covariance, we are talking about two data set. If you have only one data set, then it becomes autocorrelation, autocovariance, a relation with itself, a variance with itself. Okay, so you can calculate autocovariance, autocorrelation with itself, but not with others. With others, you have correlation and covariance. Okay.
Okay. Yeah. Thanks.
Welcome. So, any question with this, with respect to these graphs? If they are clear, then we will move to regression. Regression is a long concept, so I won't cover it today. So I will cover rest of the things. So I will cover skewness and kurtosis. They are simple concepts. So what is skewness? Skewness is a lack of symmetry. If in your data, mean, median, mode, all are equal, then there is no skewness. If mode is less than median, is less than mean, then there is a positive skewness. So this So in this graph, mean is less than median is less than mode. So when mean is less than median is less than so mode is the smallest value and mean is the greatest. This is positive skewness. So this is positive skewness. Mode is here and mean is here. So this is positively skewed. And in this scenario, it is negatively skewed because mean is less than mode. It just, the skewness tells us that how much we are lacking from the symmetry. And the formula is also simple. It's a difference between the mean and mode. So accordingly the sign will appear, and it will be your negative distribution, negative skewness or positive skewness. And we also call them as right tail distribution and left tail distribution. Yes, I will forward this presentation. Okay. So after skewness is kurtosis. Kurtosis deals with the shape of the distribution. Actually, it tells that what it tells us about the peak of the distribution. So see, these two distribution, it has a lower peak and it has a higher peak. So the one with the higher peak is known as lipokurtic, and one with the lower peak is called mesokurtic, and if it is almost flat, then it is platokurtic. So there are three: platokurtic, lipokurtic, and mesokurtic, depending on the peak of the distribution. Okay, so this is kurtosis, and we have a formula for kurtosis. So this is Kelly's formula, that Q3 minus Q1 is divided by 2 multiplied by P90 minus P10. So that's how we calculate the kurtosis. And for skewness, we have two formulas: Karl-Pearson measure, which is simply a difference of mean minus mode, and in Kelly's measure, skewness is equal to P90 plus P10.
What's P, madam?
P percentile. 90 percentile plus 10 percentile subtracted by 2 into 50 percentile divided by 2. I will mention it in the presentation.
Ma'am, could you please go to the previous slide once? Measurement of kurtosis.
Here, Kelly's measure Q3 is quartile.
Yes, Q3 is quartile and P is percentile.
Okay.
Okay. So these are the.
While doing factors, maybe understood better.
Pardon?
See, while doing practicals are live examples so that we can understand.
Okay. Okay, fine. We will take example. I will. So you can calculate all the things. Okay, I will give you a simple example. Let me open it. Even simplest in Excel. Let's take a set of numbers. So it's a very simple way of calculating all those things. Don't worry, I will do it in R also. So I just prepared a set of numbers 1 to 20. So we have mean, standard error. So standard error is the difference, is the ratio of standard deviation with the sample size. Then we have median. Mode is not there. Standard deviation. We have sample variance. Kurtosis minus 1.2. Skewness is 0. It's perfectly normal distribution. If we plot a graph, it will be bell-shaped curve. We have a range 18, which is the difference of maximum minus minimum. Maximum value, minimum. The reason it has not taken 1. 1 has been taken as header. Sum, count. So this is the simple data analytics option from with the Excel. Even Excel can do simple data analytics, and we can do that in R also. So in the behind it's calculating all those values, skewness, kurtosis. So this we have a negative kurtosis and skewness is 0. So by looking at the number itself, we can have an idea. Okay, if it is 0, then it's a perfect symmetrical graph. Kurtosis is negative, means its peak is little bit flat. It's not very highly peaked. So these we have to understand the significance of these values. We will never need to calculate them because R is a very good statistical tool in calculating all those things. But we should understand the significance of each value, how it is used. If there is a number written, then what is the meaning of that number, and how can we use it? Okay. So tomorrow I will start with regression, and with regression we will be doing more practical work because all these concepts were a little bit theoretical. But now we will be practicing all those things and we will be doing the regression analysis. Yes.
Ma'am, could you please go back to the Excel sheet? I have a few doubts in that. And could you please share the formula also what are you using to calculate in the Excel sheet?
I'm not using any formula. The Excel itself has
calculating.
Yeah, but they are using the same formulas. The formula doesn't change.
Some value is given as 209.
Yes.
In the Excel sheet.
Yes. This is simply the sum of these numbers. It's simply the sum of these numbers.
Okay, you have taken it from 2 to 20.
Yeah, it has
not
taken
from 1
2.
to 20.
Yeah, it has taken from the 2 because the first one it considered to be the header. It's like this.
Ragi, our question is,
yes.
Is there any specific reason we are omitting the 1 in the list, 1 to 20?
No, there is no reason.
Any specific reason?
No.
Because the scale is given 1 to 20. When you are saying that the minimum is always 1 and the maximum is the 20. So that case, when we are omitting the 1, obviously the values will be vary, right?
Yeah, but there is no reason. Actually, I checked in the label in the first row. So due to that, it has taken the first number as a label. That's the only reason.
First row? Then why can't the second row? I mean to say.
No. First row, ma'am has considered it as header. First row, whatever it is there.
I am correcting.
Instead of number,
they
are considered as 1. So that is the reason a bit confusion got occurred.
So I am correcting it.
Yeah, if we are considering the first row, then why can't we 0? Can we take it 0 as a header and the range from 1 to 20?
Rambabu, you need to uncheck that for us to consider one also as part of the data.
Yes.
Actually, it's a formula given by my Excel.
I didn't get it, Chandra.
Okay, I have corrected it now.
You want to? Okay, yeah.
Okay. Now the mean is everything is from 1 to 20.
Yeah, that's what we are calculating. The mean is the 10.5 and the standard error is the 1.322. and mean is the 10.5. We are considering all the calculations from 1 to 20.
Yes. Now we are
Yes.
considering everything from 1 to 20.
Okay. You are corrected, right? This is the minimum is the
Yes,
one.
I corrected it.
Okay, great.
The standard error here is standard deviation divided by number of elements in the list.
Yes. Standard deviation divided by under root of sample size.
Under root of the sample
size. Yes.
And madam, one more thing.
Square root of the.
So far we have covered statistics is for R. Right?
It is a general statistics. It's applicable everywhere. You can do it in R, you can do it in Excel, SAS, SPSS, wherever you want. They are the general concepts.
Yeah, we have covered a general concept which are useful for the model preparation.
Yes, yes.
Correct.
So you will find all these.
The same question I do have.
Yes, you will.
So, madam, one question:
Yes.
Do we follow this all the? I mean, first mean, median, mode, standard deviation, all the step-by-step procedures, or how? I mean, different models have different standards.
Okay, the thing is, when we will do predictive modeling, so all these numbers will be there. There I won't be there. We won't be going into the details that what does standard error mean. So if a standard error is then, we will understand, okay, this is the ratio of the standard deviation with the sample size, and if it is more, then yes, there is a problem, or if it is less, then we are good. So we will just keep on checking the numbers when we do detail predictive modeling, or we will do regression analysis. So that's why it's necessary to have a basic understanding what these numbers are saying. Should they be high? Should they be low? Should we worry about them, and should we not? So that was the basic idea to explain all these statistics to you. For example, in regression, we will be checking p-values. So you cannot check a p-value unless until you don't understand what a p-value is. So I will explain what a p-value is in tomorrow's lecture, and then you will, because every process in statistics will have a p-value. There is a hypothesis testing, and they will give you a p-value for that. So these numbers will keep on coming to you as and when in data analytics, statistical analysis. It doesn't matter whether you are using R or SAS or SPSS. These numbers will be there. Okay? Am I making sense?
Yeah, thanks, ma'am.
Okay.
Yeah, ma'am, one question actually. I'm just go through your blog that which was verifying it. I just found one typo. I don't know whether I'm right for that or not. Exactly.
Yes.
When we go into the R time series data,
Yes.
as you mentioned in list, so there frequency you mentioned it as 1, 2, 3, and for 1 yearly data, for 2 bi-monthly data, and 3 quarterly data, right?
Yes. Yes.
So in examples, when I see that TS and 1 to 12, 1 is to 12, the start and frequency you given it as 4.
Yes.
So I mean, I don't know exactly whether I might be right or wrong. The frequency in EPO, you have not mentioned any 4 there.
Okay, I will check it.
I'm able to. I don't know whether I'm right or not. Might be there might be some intention you'd have put there. I don't know.
Then I will check it. But you are ahead of the syllabus.
Yeah.
No, I'm just go through your blog actually, because it's very interesting for me to look into that.
Okay, so you got the blog?
Rakhi.
Yes.
Yeah.
Rakhi, even I was going through the blog when we got to your profile. It was good actually, but in some of the examples that you have given, the data is missing. The data set is missing. Actually, I wanted to practice that what you have given in your blog.
Yes. Okay.
But then I found that
Okay, just let me know where it is missing. I will update the blog. Okay. Which one you were practicing? Just
sure,
let me know.
definitely.
Okay, I will update it.
If we have it will be good if you can just share your email ID. At least we can email you. Otherwise, it will be difficult for us to send a message to you.
Okay, fine. I will share it right now. You can leave your comments on my blog also.
And meanwhile, by today,
yeah.
Okay, sure, I'll do that. In fact, I mean, I wanted to give one comment, but I think I don't know. I was not able to give it. I'll check once again.
Okay.
Yeah, and meanwhile, if you could send this, I mean, PPT that from which you took the class today, that would be good. I think even Roja suggested that.
Yeah, don't worry, everything will be on the shared drive. Actually, a lot of things are going on, and we have started yesterday with these 3 sessions. So, yeah, but we will do that, don't worry. It's
Okay,
taking,
sure.
Okay, it's taking some time, but we will put everything on shared drive. Okay?
Okay, sure. Thank you, madam.
Okay. So, whenever you feel there's a problem on the blog, just let me know or put a comment there. I will update them. And it's good. Somebody is reading
sure,
my
definitely.
somebody is reading my blog.
In fact, I read it on the first day itself. I written it down there to ask the question. I forgot, but somehow was, I think Naresh brought the topic of blog, so I remembered it.
Shri gave you the address, blog address?
Yeah, yes, ma'am.
It's there in the profile, na?
Oh, okay, it's there on the profile. Okay.
Actually, it's very easy to remember. I don't know how people will remember, but I found a very easy way to remember your address, the blog address.
Okay.
R is easy.
Yes, R is easy.
Blogspot.in.
Yeah, that's right.
Yeah, that is the right way to, I mean, read. Otherwise, if I read it individually, I mean, it will be difficult for me to remember. But if I read as R is easy, it's easy.
Yes. Okay, fine. I will do all the changes. If there is a problem, I will put it there, and I will correct it actually. And thanks for the feedback. I really need it.
Sure. Yeah. Okay. Yeah. Thank you.
Okay, so we will see you tomorrow at 9 or 8:40. Let's keep it 8:50 because my first batch finish at 8:45, so I will get a 10 minutes gap. Okay.
Sure, definitely.
Okay. So we will. Okay, so we'll start tomorrow at 8:50, 8:55. So okay, guys. See you tomorrow. So good day for today.
Thank you, madam.
Have a nice day.